So today we're going to talk about probability distribution. The last chapter was about probability of different events. Now we're going to use some variables and define probability of those variables and actually construct probability distribution. So recall that we define different variables in statistics. In statistics, we have two types of variables. The first type is called discrete variable, and the second type is called continuous variable. So what's the difference between a discrete variable and a continuous variable? A variable is denoted by x, you can use t, y, any other variables that you want. A discrete variable x is a variable that you can actually count. This is a countable variable. For example, the number of a student sitting in this class. Example, the number of students in this class. The number of emails that you receive each day. The number of notifications that are sent to you for each session. So you can actually count them. How do you represent these? You represent these with dots on a horizontal axis. What about a continuous variable? A continuous variable x is not countable. It can take on values, a range of values between a lower and a larger value on an interval. It takes values in an interval. For example, suppose you're interested in the volume. You're interested in the time or different values that can take on numbers in a range. We cannot separate them from each other. It's very hard. For example, volume, time, these are examples of continuous variables. Let's go over a couple of examples. This example says, well, which one is discrete, which one is continuous? And which one is continuous? The first one is the number of companies that lost money. So the number of companies that lost money in the previous year. Two, the volume of gasoline in 21-gallon tank. The volume of gasoline in a 21-gallon tank. There you go. So for the first one, you say that, hey, I can count the number of those companies. None, 0, 1 company, 2 companies, 3, 4, 5, and so on. It eventually stops somewhere. The key here is the use of the number of. So when you see the number of in a statement, in a sentence, it means that it refers to a discrete variable. Because you can actually count them. The second one says the volume. How do you count the volume? It is impossible. So the volume is a continuous variable. Now that we define different types of variables, we're interested in assigning a function to these variables. Let us begin by working with discrete variable. So this is our goal. We have variables. The first one is discrete variable, countable. Discrete variable x, and the other one is continuous. First, we're going to discuss discrete variable and probability distribution for discrete variable x. Then in later chapter, we're going to talk about probability distribution for a continuous variable. The probability distribution for a discrete variable like x is denoted by p of x. P of x. So what is p of x? P of x actually assigns the probability for that variable x to it. P of x is the probability of x. A discrete probability distribution for discrete variable x has the following properties. For a discrete variable x has the following properties. First of all, remember that the probability of an event or a variable must be a number sandwiched between 0 and 1. So probability of variable x is in between 0, 1. We don't have probability like 1.5 or a negative probability. Note that since x takes on different values, x can be 0, x can be 1, x can be 2. Remember the number of companies that they lost their money last year. No company, it means that you have x equal to 0. One company, it means that x is equal to 1. Two companies, x is equal to 2, and so on. So if you take all of those probabilities, add them together, it must be equal to 1. The sum of all probabilities must be 1. So mathematically, we write it this way. We say that the sum. So this is summation notation. The sum of all probabilities p of x, while x is changing, must be equal to 1. What's the meaning of this? It means that if x is equal to 0, I have to find the probability of x equal to 0. plus, after calculating this, I need to find the probability when x is equal to 1. Then, after calculating this, I need to calculate the probability that x is equal to 2, plus the rest of the probability. It has to stop somewhere. P of, for example, x is equal to 1. When you take these, all of these probabilities, add them together, it must be equal to 1. So let's go over some examples. How do we actually calculate these probabilities and how we can visualize them? So we introduce a variable, discrete variable x. Then we define the probability for that variable x, p of x. And now we're going to talk about different examples. When we have an example, how we can make sure we have the probability distribution for that variable and how we can visualize that. So let's take a look at this example. This example says, well, we have the following information. An industrial psychology administered a personality test for passive-aggressive traits to 150 employees. So we have 150 employees. Each individual was given a score from 1 to 5. And this is the table that they use to summarize all of this information. In this table, they have the score. The score is X. And we have the frequency. Remember that we have 150 employees. Frequency, F. So score 1, the meaning of score 1 is extremely passive. Score 1, how many? We have 24 employees who had score 1, the first trait. Score 2, how many? We have 33 employees. Score 3, 42 of employees got score 3. 4, we have 30 employees. The frequency is related to the number of employees, got score 4. And finally, score 5, we have 21 employees with score 5. Okay, perfect. Do we have a discrete variable or continuous variable? Since we can count the number of x values, it means that we have a discrete variable. So since we have a discrete variable, we can easily calculate each probability, each p of x. So how do we calculate the probability? The probability of x is equal to the frequency of x divided by the sample size. So we get the frequency of x divided by the sample size. Perfect. So let us find the probability for each of these x values. We start by x equals to 1. Score is 1. The probability of x equals to 1, or to simplify that, you can just write p of 1 is equal to. So what's the frequency of score 1? The frequency of score 1 is 24. 24. Divided by the sample size. What is our sample size? 150. If we do the calculation, we get 16% or 0.16. So what's the meaning of this number? It means that 16% of employees got score 1. Okay, I found the first probability. Let us move on to next probability. What's the probability x is equal to 2? Or in a compact form, in shorter version, what is P of 2? P of 2, score is 2. How many? 33. So we got 33 as the frequency of the second category, the second score, divided by 150. This gives us 22%. So you say that 22% of the employees got score 2. They belong to the second category. P of x equals to 3, or in short version, P of 3 is the frequency, the number of employees who belong to the third category. Got score 3 is 42, divided by 150. Let us do the calculation. When we do the calculation, we get 28%. 28% of all of those employees, they belong to the third category, they got score 3. Let us find the probability that x is equal to 4, or P of 4. This is equal to, well, the fourth category, score 4. We get 30 employees out of 150, which gives us actually just 20%. 20% of all employees got score 4. And finally, the probability that x is equal to 5, the probability that they belong to the last category. What is that probability? It is, in short version, P of 5 is equal to the frequency, the number of employees who belong to the fifth category, 21 of them, out of the total, which is 100. This gives us 14%. 14% of all of those employees, they belong to the fifth category. Okay, we found each of these probabilities. If we add them all together, it is equal to 1. And as you can see, each of these are numbers between 0 and 1. So P of each x is in between 0 and 1. You can investigate that. And if you add all of these probabilities, 16%, 22%, 28%, plus 20%, plus 14% is equal to 100% or 1. The sum of all of these frequencies is equal to 1. So now I expect you to ask, how do I visualize this graph? The graph is actually very simple. To graph this, we have horizontal axis and we have vertical axis. On the horizontal axis, you list all of your x values, or the representative for each category. On the vertical axis, you have what you see here. You can actually see you have your relative frequencies. Relative frequencies. What's the relative frequency for the first class? It is 16%. Relative frequency for the second class, 22%. Relative frequency for the third class, 28%. Relative frequency for the fourth class, 20%. And relative frequency for the fifth class is just 14%. The maximum is 28%, so let us scale this by 30%. 0.30. Perfect. So these are representative of each class. 1, 2, 3, 4, and 5. Well, we're going to graph a histogram. No gap in between bars? Well, the relative frequency for the first class is 16%. Since 1 is the representative for the first class, we're going to just move these bars the way that 1 is the representative of the graph and it stops at 16%. And it stops at 16%. So 0.16. This is the first bar for your histogram. The second category has relative frequency 22%. 2 is the representative for the second category, 22%. So we're going to just go a little bit up. And 2 as the representative for this class, 22%. Next bar is related to the third category. 3 is the representative for this category, and the frequency is 28%, the highest frequency, 28%. 0.28. And 4, this is the representative of the fourth class, and the frequency is 20, so 20%, 0.20, and this is your bar here. And finally, the last class has representative 5 with frequency, relative frequency 14%. So here we go. This is your last. This is our histogram. There is no gap in between these bars. If you use gaps, it means that you don't have a histogram, you have a bar graph. So all of these need to be next to each other with no gaps in between. So as you can see, the relative frequency and the probabilities are the same. So instead of writing, you have relative frequency. Since we are learning something new, you can just write probability of X. And your vertical axis can be renamed to P of X. Probability distribution for variable X.